Dear all, I am here to detail about the experiment based on the beam. The name of the experiment is simply supported beam apparatus. This is the beam. It is a horizontal member of length 102 centimeter, and this is the mid of the beam 0, and from here to this end it is a 51 centimeter, and at this end left side it is also 51 centimeters. There are two supports at the either ends, left side and right side. String balances are attached with the both supports, and support name is here simply supported. Aim of the experiment is to determine the reactions of the simply supported beam. So by applying external forces, for that we will apply some loads, and there are two hangers and there are grooves on the beam for placing the hangers with loads. So by applying the external forces, or you can say active forces, we get here reactive forces. Means whatever deformation will be there, that will be here displayed in the spring balances. Spring balance is kg. The long scale is mounted over the length of the beam, and the beam is a horizontal member, and there may be different kind of loadings like point loads, distributed loads, uniformly distributed load, uniformly varying loads. So here these are the 2 point loads. And regarding types of supports, so here it's a simply supported beam because the beam is simply supported by two supports, and there are various types of supports like a simply supported beam, fixed support beam, overhanging beam, cantilever beams, continuous beam. So as in this simply supported beams, the loads are at the both ends. As there are some errors in both the spring balances, that's why to compensate that, these some loads are kept here. And in simply supported beam, the supports are at the ends. It can be also converted as the overhanging beam by suppose we uh, provide reactions in between some length, not at the ends but in between. Suppose this support reaction we provide here, this we provide here, so that's why it becomes the overhanging beam. But here both the support reactions are fixed at the ends, so here we can only use it as simply supported beam. So once again, regarding apparatus required, a horizontal beam, you can see here weight of different masses, then long scale, then spring balances. Now how to take observations? So one can see there are loads W1, W2, because 2 point loads are there, that's why W1, W2 means these are the weights. Distances from the supports. Suppose from these, suppose we are giving the name the and A. This we are giving name and B. So some distance like 10 centimeter from the ends, from the both side, 15, 20. Also, along with the varying the distances, also we can vary the weights, or we can keep, suppose weight we can keep constant and the distance we can vary. Distance we can keep constant and the loads can be varied. And whatever readings will be here will be displayed on the both spring balances. Then we have to compare the theoretical reactions which we get from the calculations and the experimental reactions. Then we compare, we get percentage of error in both reactions at A and a reaction at B.
As explained earlier, we can measure the reactions, and we can, for measuring the reaction, we have to apply load. For applying load, we can use certain combination here. Either we can increase the load, or we can change the distance, or we can do both for each observation. Here initially I have applied, for taking first observation, I have applied a load of 1 kg in each of the hangers, and the distance of load W1 from end A is 20 centimeter, as we can see here, and load W2 from end B is 15 centimeter. And we can also check on the reactions at end A, that is known as RA. Here RA is 8.5 kg, sorry, 0.85 kg or 850 grams, and here the reaction is 1.05 kg or 1050 grams. For second observation, again we can raise the distance or change the distance. So I am changing the distance for W1 without increasing any load in this member, and for W2 I have here changed the distance as well as also increasing the weight in this hanger. So here the distance of W2 from end B is now 25 centimeter, and from end A the distance of hanger W1, weight W1 is 30 centimeter. Now for taking third observation, again we can increase the load or change the distance. So I am, for W1 I am changing the distance as well as increasing the load. Here I am applying a load of 1 kg at W1. So now total load acting as W1 is now 2 kg, and I am not increasing the weight, just changing the length in W2 member. So now we can take note of the reactions acting in both the members. Here RA, it has a reaction of 1.7 kg at RA, and reaction RB at end B is 1.6 kg here. So we can now we can calculate the theoretical reaction at both the ends for these different kinds of load by using formulas listed in the manual. In the similar manner, we can increase the loads and also we can change the distance for taking different observation. Here in this experiment, at least we have to take 4 or 5 observation. As I have already explained about three observations, we can further do different observation, at least 4 or 5 observation we are needed.
This is the beam we have considered in our study. It is simply resting on the surface, and one can see it is allowing rotation, allowing horizontal movement, but not allowing vertical movement. We can see the example of simply supported beam here in the structure in bridge. In a previous figure we have seen the beam was simply resting. That's why at the both ends the horizontal movements were allowing. Here, if support reactions are, suppose one end is supported by pinned or hinge support and another is supported by roller support. So one can see pin support reaction will allow only rotation. It cannot move downward, upward, vertically, and horizontally, left side, right side. It cannot move in case of hinge or pinned support. But in case of roller support, it can move horizontally, left side, right side. It can also rotate, but it cannot move vertically downward. And this is the deflected beam when load is applying. So how deformation occurs. As now theoretical values of reactions are required, which can be compared with the experimental values which are observed while doing experiment. So as there are two reactions are acting, RA and RB, and 2-point loads W1, W2 at a distance A and W2 at a distance B from the end B. Total distance of the beam is 1.02 meter. So taking moment about A, so summation of moment is equal to 0, and clockwise we are taking here positive, and W1 load 1 is multiplied by the distance from the end A, this is the end A, and plus W2, and for that distance will be what? 1.02 minus B, means we need to subtract B from the total distance 1.02 meter is equal to the support reaction RB and multiplied by this distance, in which we get from this we get RB in terms of W1, W2, and again we are applying the equilibrium condition for the vertical forces, as there are no horizontal forces are acting. That's why we are considering the equilibrium, taking equilibrium at vertical direction. So vertical directions, suppose we take reactions, so RA, this one, RB, this one, both are acting upwards and both the loads are acting downwards. That's why A is equal to W1, W2 we have taken, and from this we can take RA, and in this way we get the theoretical reactions. Now we have to get the percentage error for RA reaction at A and the percentage error for reaction at B. So it is equal to, suppose RB we are taking, so RB, the theoretical value what we get here from the calculation, and what we observed from the experiment, divided by minus divided by the RB theoretical value. Once again, it is the difference between the reactions we got from the theoretical values and got from the experimental, divided by the theoretical value of reaction. So in this way we can get the percentage error of both the reactions. Now let's visualize the shear force diagram and the bending moment diagram of the beam we have considered in our experiment. So shear force is what? Shear force is the all the parallel forces acting on the beam, means summation of the forces, vertical forces acting on the beams, including the applied loads or the reactive forces. So it is summation of those vertical forces. And bending moment, it is summation of the moments acting on the beam over the length. Shear force diagram is the variation of the shear force over the length. The bending moment diagram is the variation of the bending moment throughout the length. And here, why shear force is considered? Because the deformation occurs much more in the you can say the lateral direction rather than the axial. Now we are considering the beam here. This is a beam calculator online, and suppose I am taking here 1.02 meter. Our beam length is this one, and need to go back. Supports are which kind of supports? So one pin support at 0 distance, I am adding it, and the another is roller support at 1.02 meter. It is our length of the beam, the simply supported beam. And next, the loads we have to show, represent. So 2 point loads are acting. Suppose we are taking one the distance 0.3 meter from the end A, and it's the magnitude. Suppose we are taking 1.5. Okay, and again the point load, suppose value is 2 and at a distance 0.7 meter from the end A, the value 2 kilonewton. Yeah, so in this way now we have got the beam, simply supported beam. There are two supports at the ends, and the 2 point loads are acting here. Now we want to know about the shear force diagram and the bending moment diagram. So it is the bending moment diagram, one can see here, and one can see the zero values of the bending moments at the supports here and here. Means there will be no moments at both the supports. Our support side obviously the moment go that will resist. As there is a 1.5 load, so corresponding to this value, uh, it is up to here, and it is varying linearly, and the maximum values corresponding to maximum point load 2 kilonewton. This is the maximum value, and similarly the shear force diagram, the variation of shear force along the length. So one can see uh, the bending moments are zero at the supports, but due to reactions, this is the reaction. This value represents the reaction at the support A. This is the reaction at support B. So in this way, the shear force diagram is shear force is varying along the length. There are some observations in the right side regarding the maximum and the minimum values of bending moment, shear force. So in this way one can visualize, and how it got deflected. The beam got deflected in this way one can see. Yeah, in this way we have performed the experiment. We found out parallel forces. We determined the reactions at both the supports theoretically and practically. We also verified the percentage error in both the supports. Also, we have shown the shear force diagram and the bending moment diagrams, and we came to know the nature of deformation about the beam. Why shear force is more significant here? Because whatever deformation occurs, that is much more greater than the actual deformation. Here, the deformations are more significant in the lateral deformation. That's why we have also shown the shear force and bending moment through the diagrams. Thank you.